So, good day everyone. My name is Enad, and now we are gonna tackle about topic 3, which is size reduction and separation of solids. So we are group 7, and these are the members. And let's start. Size reduction. So the contents are definition of size reduction, introduction, objectives, advantages and disadvantages, mechanisms, size reduction by hammer mill, and size reduction by ball mill. Next slide. So what is size reduction? So unsa man nay inyo kuan unsa ang size reduction? So if wala, ako na lang magkuan kung unsay definition. So size reduction is defined as a process of reducing large solid unit masses, vegetables or chemical substances into small unit masses, coarse particles or fine particles. So mga large object like vegetables or chemical substance ipang pagamay. So i-reduce ang ila size para kang ang example aning sa kanang chemical substances kanang sa mga pharmaceutical kanang mga medicines kana mga example madagko na sila gipagamay para maigo sa capsule. So next slide. Pharmaceutical powders are classified as monodispersed. So monodispersed meaning same sizes, particles of same sizes, as well as polydispersed meaning particles of different sizes. So para sa ako ingon kanina pharmaceutical powders. So mga ito ako ingon na kung pwede sa mga medicine kanang mga powder sa sulod sa mga medicine or anything mga pulbos may ngano. So next, particles of monodispersed type are ideal for pharmaceutical applications. So kung sa ako gingon kanina, pharmaceutical applications, mga medicine or mga pulbos, whereas polydispersed powders create considerable difficulties in processing for production of dosage forms. So, syempre, mag-sugod ka kay kung polydispersed, meaning different sizes sila, di sila uniform. So, kung mag-dosage ka na mga 25 ml, mag-sugod ka. So, in order to obtain uniform size particles, powders are to be reduced in their size by size reduction. So, dili na masulod ang size reduction. Size reduction involves techniques to create new surfaces and increase surface by adding energy proportional to the bonds holding the feed particles together. Next slide. So objectives. There are two main objectives. The first one is the main objective of size reduction is to produce smaller size particles from larger ones. So sa mutable naman, i-explain naman na kanina. So next one is smaller particles are the desired product either because of their large surface or because of their shape, size, and number. So next, other objectives are to increase surface of solids to enhance the rate of dissolution. So kung mas gamay ang imo particle, mas dali siya ma-dissolve. So mauna pagamayon ang mga particles para mas dali siya ma-dissolve. So to meet stringent specifications of the sizes of commercial products, Next, to accomplish and improve intimate mixing of solids in a solid to solid operation. So, kung mas gagmay ang mga particles, mas dali siya ma-mix kung uniform and mas gagmay ang sizes sa mga particles. So, to increase the therapeutic effectiveness of certain drugs. So, para daw ma-increase ang effectiveness of certain drugs or medicines. To improve physical appearance, flowability, and compression of those uniformity of products. So, para mas madali sila, mas ma-uniform ang dose sa mga kanang mga medicine o bisag man sa ng product na kinahanglan ng mga dosage. To enhance stability of dispersed systems such as emulsion and suspension. So next slide. So the advantages. The first one is content uniformity. So parehas nga akong sabihin kanina, content uniformity dapat same sila og sizes tanan para dili ka maglisod sa mga dosage. So mixing turns out effective only when the ingredients are small and uniform of size. So sabotable naman sa nakaingon. Uniform flow. If the size of particle is small, the flow of powder into dyes during the impression of tablets is effective. So next, effective extraction of drugs. Penetration of solvent into time or cells of organic origin becomes rapid when the particle size is smaller. So next, effective drying. If the size of granules is small, then the drying of granular mana becomes rapid. So mas dali daw siya mo dry. Improve physical stability in suspensions and emulsions. The rate of sedimentation decreases if the particles are of small and uniform sizes. Improvised rate of dissolution when the surface area is larger than the dissolution of some substance increases. Thus, size reduction facilitates in increasing the surface area. Improve absorption rate. Smaller the particle, the faster is the absorption because the solution is also enhanced. So, mas dali siya ma-absorb kay mas dali man siya ma-dissolve. Pares anang maginom kag medicine. So, dali ra siya ma-absorb kay smaller size man siya. Mga smaller particles, mas dali ra siya ma-dissolve sa sulod sa talawas. So, the disadvantages are, first one, drug degradation. Decomposition of drugs can occur due to excessive heat production during milling. Another reason is increased surface area also contributes in drug decomposition. So the second one is poor mixing. Generally, very fine particles are subjected to strong cohesive forces, hence aggregation of particles takes place. But this aggregation inhibits the efficient blending of different ingredients.
For the continuation, mechanism of size reduction. So there are 4 types of size reduction. First, the impact, next attrition, next shear, and lastly the compression. So first, the impact. So particle is more or less stationary and is hit by an object moving at high speed. Our example is the hammer. So first, let's see the video. So, as you can see in the video, in impact, there are three types of impact. Either the big particle hit on the force or the hammer, or the hammer hit the particle. And in the third type of impact is when the two particles collide each other. The best example of this impact of this mechanism is the hammer mill or the fluid energy mill. So next, attrition. So attrition, breaking the edges of the solid either by impact or particle collisions or arising from particles scraping against one another or against a rigid surface. So in this type of mechanism, attrition, so the particle will rub to a surface in which cause a friction in their collision. So it will break the edges of the solid either by impact or particle collisions or arising from particles scraping against one another. So scraping one another means rubbing to each other. And the best example of this is the fluid energy mill, in which the surface of the stationary surface will be rubbed to the certain particle. So next, shear or cutting. So the material is crushed by means of a sharp blade or blades. Okay. So first, cutting. So the material is cut by sharp and thin knife. It is used for size reduction of waxy substances or fibrous material. And the best example of this is the cutter mill. So it's obvious. So the new surface created is less damage. So in this type of mechanism, cutting, when the material is cut, so the new surface created is less damage compared to the other type, like the first type of mechanism in the impact, because the impact when the impact type of mechanism is used, the material is more likely damaged. So next is the shear. Also, shear is the combination of cutting and crushing. So equipment consists of both knife and bars. So the best example of this is the colloid mill, in which the new surface of this is more likely damaged because there will be crushing and at the same time there will be cutting. So next, compression. So compression particle is crushed by two rigid forces. Example, nutcracker. Oh, as you can see in the video, it's obviously the material is crushed between two rigid forces. So there's two rigid forces, and in between, the material will be go in and integrate, and it will go into smaller pieces. So particle falls between two rigid rollers and disintegrate into smaller pieces. So that is the meaning of the compression. So for the continuation, mechanism of size reduction, modes, cutting, compression, impact, and attrition. So as a description, I will read it to you. Material in cutting, material is cut by the means of sharp blades. Type of material, fibrous and waxy substances. Cutter mill, and also I will add the the mechanism of size reduction. It's from bigger particle to smaller particle. So it vary to the type of material. When we use size reduction, the important is the type of material. So mill following the given mode is the cutter mill. Next, the compression. Material is crushed between the rollers by applying pressure. So type of material, soft materials. And the best example of this is the roller mill. Next, the impact. In this, the substance is subjected to hammers or bars at high speed. Impact also occur when a forceful particle is struck against a stationary object. Almost all drug the type of materials, almost all drugs are size reduced by hammer mill. So fluid energy mill is used for moderately hard and friable materials. Best example of this, hammer mill, fluid energy mill, and ball mill, and the attrition in this breaking of material colliding it between two surfaces. Type of material, brittle drugs, and the mill following given mode is the ball mill and fluid energy mill. So that is all about. So for the next, my group mate will be discussing.
Hammer mill. Size reduction by hammer mill. So by definition, a hammer mill is an essential machine in the pharmaceutical industries. It is used to crush, pulverize, shred, grind, and reduce material to suitable sizes. So mauni siya ang hammer mill. So usually, ginagamit niya sa pharmaceutical industries. Ginagamit siya sa pag-grind sa mga raw materials sa pharmaceutical industries like mga oak bark, mga leaves, mga roots like mga ginger, nana. Then ginagamit po ni siya sa farm. So next is a hammer mill part. So morning part sa hammer mill. So first is the motor shaft dire. Then next is the feed kung asa ibutang ang mga material, kung asa isulod. Then next is ang casing. So morning casing. Then ang hammer. So morning hammer ang mag-impact sa imong mga materials kay gatuyok man ni siya. Kaning hammer mill. Gatuyok ni grabe ka paspas. Then next is ang screen. So kanang mga murag na bangag-bangag nga part sa hammer mill mo na siya ang screen. Then mo ni diri mo sa screen dayon mo lusot ang mga fine products katong mga gagmay na gid nga pwede na maigo sa ani nga mga bangag. So next is mo ni ang video sa hammer mill. So mao ni siya working of a hammer mill. So mao ni siya. Sa feed ginasulod ang itong mga material na yung mga bark, mga ginger. Then pagkasulod saya kaning hammer mao'y mag-impact saya, then magkaano siya, mapulverize ni siya, ano siya, ma-shred siya ani mga materials nga mosulod. Antod nga mapulverize sila, then ang kaning mga gagmay na nga pieces mahulog din sa screen. So another video sa hammer mill. O kani siya mo ni. Mura siya mga bato nga gisulod. So mo na siya nahulog. So mo ni gituyok ang hammer. Mo ni mga hammer. Then mo ning raw material ang feeder, mga raw material na gimura ginahapak sa sa hammer. Ginapulverize dayon ang mga gagmay na materials kana molusot sa bangag sa screen, mga hulog na dayon. So maura na siya ang hammer mill.
So good day everyone, I'm Romero and I'm going to discuss about the ball mill. Size reduction by ball mill. So a pharmaceutical ball mill is a type of grinder used to grind and blend materials while manufacturing various dosage forms. So the size reduction is a ball mill is done by impact as the ball drop near at the top of the shell. According to the need, ball mill can be either wet or dry design. So ball mills have designed in standard size of the final product between 0.074 millimeter and 0.4 millimeter diameter. So this is ball mill. So this is the principle of the operation of the ball mill, and this is what it looks like in industrial mill. So this is the ball mill in 3D. As we can see, there's a clinker input, airflow in, motor which is circa 4.5 kilowatt for 100 p per hour mill, and the rotational diameter speed depends on typical 15 rev per minute, and the cement output which is air sweep upwards, gravity downwards to elevator. And we can see the second chamber which is it is rolling motion causing grinding, usually 60 to 15 millimeter, and the first chamber which is 90 millimeter ball charge cascading motion causing grinding, and the diaphragm which is giving the machine an airspace. Ball mill speed. So this is how it looks inside the ball mill. So A, which is the low speed, B, high speed, and C, the correct speed, which is the constant speed. So ball mill mechanism. So we're going to show the speed mechanism inside a ball mill.
In this video,
ball mill
we will
works.
talk
So in
about
this
the
slide,
working principle
you
of
can
ball
see
mill
a
machine.
video about the ball mill with its full mechanism, especially
The ball
for the
mill
other
is
parts.
mainly composed of a cylindrical barrel, a feeder, the drive bus, the large ring gear, and a motor. The grinding operation is carried out in the barrel of the ball mill. After the grinding medium in the rotating barrel is brought to a certain height, the medium will fall due to its own weight, and the ore contained in the barrel will be subject to the violent impact of the medium. On the other hand, the grinding medium revolutes and rotates along the axis, and the crushing and peeling forces on the ore will be generated between the grinding medium and its contact area with the barrel, thereby grinding the ore. The ball mill steel ball is lifted and raised to a certain height when the cylinder rotates. Due to the gravity of the steel ball, it finally falls along a certain track. The steel ball in this area is subject to two kinds of forces. One is the force supplied to the steel ball from the tangential direction when rotating. The other is the force that is symmetric to the diameter of the steel ball and is opposite to the above force. The above two kinds of forces will form a pair of force couples for the steel balls. Since the steel balls are squeezed between the cylinder and the adjacent steel balls, the force couple will cause friction forces of different sizes between the steel balls. When the ball makes a revolution with the axis of the cylinder, it is thrown from top to bottom in the area, and it has a strong impact on the ore of the cylinder in the area, breaking the ore. It can be said that the ore in the mill barrel is mainly ground by the action of abrasion and peeling force, impact force, and squeeze force. Have you understood the working principle of ball mill? If you have any questions, please subscribe our channel. We'll publish more videos about ball mill.
Separation of solid. The separation of the components of a mixture is a problem frequently encountered in chemistry. The basis of the separation is the fact that each component has a different set of physical and chemical properties. First is a mechanical separation. Mechanical separation often by hand takes advantage of physical properties such as color and shape. For example, recycling plastic, paper, or material. Here's a quick video to enlighten you guys.
Separating solids from solids. Hand picking. Before washing rice for cooking, we first remove the paddy, husk, and stones from the mixture. This method is commonly used for separating slightly larger sized impurities like the pieces of dirt, stone, and husk from wheat, rice, or pulses.
Mechanical separations means separating material by a hand or mechanical methods such as screw, grinder, and etc. Next is a magnetic separation. Magnetic separation takes advantage of physical property of magnetism. For example, separating metals in a scrapyard. Here's a little demonstration. Magnetic separation is separating materials by using magnet to attract magnetic properties. That's all, guys.
Good day, everyone. I am Jon Eli from Cagampang. I will be reporting about methods of separation of solid. Filtration takes the advantage of the physical property of the state of matter. A screw lets the liquid particles through, but traps the solid particles. In some processes used in the production of chemicals, both the fluid filtrate and the solid filter cake are recovered. The art of filtration was known to early humans to obtain clear water from a muddy river by scooping a hole in the sand on a riverbank to a depth below the river water level. Clear water filtered by the sand would trickle in a hole. The same process on a larger scale and with refinement is commonly used to purify water for cities. Examples of filtration is filtering coffee or sugar. If there's a filter coffee, pour hot water sa coffee grounds, then ay mo rin extract little coffee ground beans. Next, filter can be also used to separate solid particles of different sizes. Example again, window screens. Separate them ampule specific space. And air filter assembly. That also should be there. So kami siya guys kay then kung natin fine medium then coarse thinner particles, medium particles, larger particles. So kailangan siya. So magsugod na siya glue para mabahin ang mga particles. Yeah, hindi pang filter out. Siya, different sizes sa particles yung siya pinaka-thin is ng size and that's yung mga particle size. The different levels of filtered particles. So, for other ways, we can do pour off it would do another solid behind.
takes advantage of difference in density. So something like water from rice. The layer closer to the top of the container, the less dense the two liquids, or the liquid from which the precipitated sediment has settled down is poured off, leaving the other component or the dense liquid of the mixture behind. Let us watch a video about the candle. So guys, as you can see, ang mga soluble particles sa liquid, gilatan ng mga nasa to down at the bottom of the container. Ang tawag din ano ng mga particles kay sediment. Ang process by which ang clear water obtained after sedimentation is transferred sa light container without disturbing this sediment. Ang tawag din ang process ay decantation. Next, distillation. The separation of a mixture of based on the physical property of boiling point. Example ay the distillation of alcohol or oil. So there's an example ay distillation tower or steel used in crude oil or refining. So what should a column? Then siya ang hot crude oil. Ang hot crude oil is kaya more siya ang unprocessed na oil, hindi pa nakuha sa land or sea. Once pag-boiling point mo siya, dito mo yung hot crude oil. Once boiling point mo, then mo evaporate na naman sila yung hot vapor rising. Ayun. Then dahil sa taas, good guys, yung nakatap kayo, hindi siya tayo naman kuha. At boiling point, once mapangkat na yung hot vaporizing ang boiling point, okay, mo rin siya tayo condense liquid. Then na-finish din ang level guys. Dahil nga level, dahil pa lang na point rather, okay, nanalig mo condense ang liquid. Then mahimo, let's say, for example, basic, then dahil nga liquid day. At dahil na condense liquid na form, dahil pang cool or hot, vapor, petrol, I mean, kerosene, dahil na level, para siya guys sa distillation. Dahil example, nakasulat sa simple distillation.
ba sa video, ang first button, pagdagan of cold water ang condenser. Then heat will be applied sa mixer para ma-distill. Pag mag-travel ang vapor sa condenser, it ma-liquefy na din siya and will turn into droplets, which is called distillate. Siya dahil ang process of distillation and practice. Thank you guys.
So for the continuation of methods of separation of solid, number 6 is evaporation. So vaporizing liquid and leaving the dissolved solid behind is used to separate solid solution. So for example is obtaining sea salt and from seawater evaporation ponds. So to see how evaporation works, here is the video of the solid separation.
In this activity, we shall demonstrate how to separate salt solution by the process of evaporation. We have taken a glass of water and we are going to mix a spoon of salt into that. We'll stir it till the salt fully dissolves. Now we are going to pour this salt solution in this vessel and boil it till it evaporates. As you can see, the water has evaporated, leaving behind a salt. Now the water has fully evaporated, leaving behind a salt. So in this activity we can see how to separate the salt from the salt solution by the process of evaporation.
So for the next method, the last method also is centrifuge. It is a circular motion, helps denser components sink to the bottom faster. So as you can see in the illustration, inside of the armored casing is a tube, and before the tube is filled with supernatant and pellet. So before, the pellet was scattered inside the tube, and after it's rapidly rotated, the pellet became denser and sink to the bottom. So further knowledge about the centrifugal separation, here's the video to show how it works.
The power to separate, the strength to innovate. Separation takes place at a temperature of 50 degrees The continuous separation process starts when the product is gently introduced into the bowl through the feeding pipe and the distributor. It then flows into the rising channels and is separated through spaces between the discs. Separation takes place inside the bowl as a result of centrifugal force and the different specific weights. The light phase is concentrated in the inner part of the bowl, while the heavy phase is forced towards the outer part of the diameter. Any solids particles are forced towards the outer part of the bowl by the same centrifugal force, accumulating in the solids holding space, and are discharged automatically in very precise shots at regular preset intervals. Both the light and heavy phases rise along their respective paths and reach the centripetal pumps. As a result of the centrifugal force generated by the rotating movement, they are ejected from the separator. Innovation, reliability, quality, efficiency. Three-phase centrifugal separator, maximum reliability, and highest efficiency separation.
So that would be all. We hope that you learned a lot of our discussion. Thanks for watching.